Okay, so kia ora guys, welcome to session number 6 of IBM Systems Back to School 2020. I'm Abedu, I will be your host, or I'm being the host for the other sessions as well, so nothing new here. But today we're going to have a very interesting topic about some option that we have on distributed environments or low compute platform, whatever you want to call it, that we have on our shelf, not only for big banks and huge organizations, but for medium and small in medium business, where we have this thing called LinuxOne, which I reckon that Pat will wow you today about it. So if you can just go to the next slide, Pat, so we can just show what we have. Yeah, okay. So yeah, this is the series. It is an eight session series. We are in the session number 6, 2 to go. In theory, we are taking like from 30 to 40 minutes and of lecture, and then 15 to 20 minutes of questions and Q&A. So prepare your questions, and hopefully we can answer all the questions as we go through, okay? Pat, I don't know if you want to just want me to stop you when a question occurs, or you want to just leave for the end. It's up to you, okay? If you want to do like a pause in the middle and check the questions, that's totally fine. It's your show, okay?
Yeah, there probably is a logical place before I start going into some client examples. So yeah, I'll check halfway through, sort of thing.
Okay. So next slide, please. So yeah, well, so we're the speakers. Barry White, master inventor in ATS for IBM worldwide. Myself, expert on storage for New Zealand and AP as well. Oughton, Hurricane supporter in special Auckland Blues say hi. Andrew G is been at IBM like more years than like most of us here on the team. So very experienced guy, and also did 3 beautiful sessions last week in Power and in Power Systems mainly. Okay, the sessions. Next slide. So this is our agenda. So we started on mainly half of a month of May, and we are heading towards our end of this event. So I hope you're enjoying so far. The next 2 sessions are in July. Is with me about managing protecting data. But this is not about storage today. This is about mainframe or LinuxOne, or maybe Pat has a new fancy name to call it. Pat was here and I disappeared. So yours.
All right. Cheers. Thank you very much. No, there is no new fancy name. This is it's definitely LinuxOne. We'll start with a little bit of history and then go into some specs about the 2 available machines, and then roll through into why it's a good idea and sometimes why it isn't a good idea, and then a couple of client examples. 2 we can name, 2 we can't, but all the information's there, and there'll be plenty of time for questions, hopefully. I might shut the video off because the lighting and stuff isn't too flash here, but we'll just kick on. Hang on. Okay, here we go. Okay, so apologies for the slide being 1 year or a year and a half out of date, but that's what I was given from my people. So Linux was invented or developed in 1991-92 by Linus Torvald. Very much development toy, really. No one really considered it to be enterprise class. But sometime in the late 90s, some people at IBM and a college in America just up the road from where the mainframe or the LinuxOne is now developed started playing around, and they developed their first drop of Linux on S390 as it was back then. It was still a Z box, but it was based on Red Hat, because that seemed to be, at the time, they were the guys who were more willing to make changes to the upstream code. So in 1999, first one came along. A year later, SUSE officially supported us. A year after that, Red Hat followed suit. And then a year later, SAP and Oracle became the first two major ISVs who were developed and fully supported code running on LinuxOne, at the time, a mainframe. IBM introduced an engine on these machines, a specific CPU categorization called an Integrated Facility for Linux, an IFL. And the key thing that didn't force customers, but encouraged customers to uptake and use Linux on the Z boxes, was that this engine did not incur any normal software charges. So if they were traditional mainframe customers, using a whole engine to run Linux was going to increase their monthly costs. The IFL avoided all of those costs. So yeah, that started going 2002, and then for the next 2 or 3 years, it was a slow trickle of growth. A few ISVs came along. IBM ported a lot of their applications that were on Linux on other machines to be Linux on Z as well. And then in 2007, IBM worldwide decided to drink from their own Kool-Aid, I suppose. They'd been preaching about server consolidation and the benefits of reduced footprint, reduced power, reduced management, and they started this project called Big Green. So around the world, they consolidated 3,900 servers, Linux servers. They were bare metal as well, because there was no real virtualization stuff at the time, to 30 mainframe servers around the world. So they reduced the size of their data centers, and in some cases shut their data centers down. The rest of this chart just shows the major software drops and major hardware drops. Hardware across the top, software along the bottom, and the blue line is the incremental growth. There's no scale, but we can get the exact numbers if anyone really wants them. In terms of engines and MIPS shipped for Linux only, not counting ZOS for the traditional bank workloads and things. So the first LinuxOne machine was announced in late 2015. That was where IBM officially branded a machine that was Linux only and developed off the back of the mainframe technology that had been going on for 50 years. Okay. So why are we doing this? Two server ranges, one for the low-end customers and one for the massively high-end customers. So this is the ones available on LT1, which is the 4-frame, goes from 1 to 4 frames. Is for the high-end guys. They are a maximum of 190 cores or IFLs. Processor, it's all on the charts. The processor speed is the highest available microprocessor out there in the marketplace to this day. There's not really, I don't think it's going to go much higher. It's been pretty stable for the last 2 or 3 generations. A typical core consolidation for the LT1s is 10:1. But some, depending on what the workload is, some customers, if it's just dev test workloads, you'll get 30:1. So you could see up to, 8,000 core consolidation, tiny little machines onto 4 frames. The LT2 is the one that was just announced this year. It's a single frame, standard, 65 cores maximum that the customer can use. So you're talking 560 cores of x86 if you get a 10:1 ratio. You can hard partition it. You can run ZVM, which is one of IBM's operating systems. You can run KVM, which is just the Linux virtualization stuff, or you can run each LPAR as a separate guest. There's multiple ways to skin it, really. It just depends on what your workload requirements are. I don't know if anyone's interested in the hardware side of it, but on the bottom there's a link that says the IBM Interactive Product Catalog. I don't even know how many IBMers know this exists. It's a interactive website where not only is the storage available, but you can click and take the covers off servers and pull apart little bits of hardware. It's all animated. You just click the bit you want and it'll take you through and give you a little bit of information. If you're hardware inclined, it's quite interesting. Next up, so LinuxOne. So the LT1, the scale of the LT1, we have up to 190 cores available for Linux. These are what you would consider a core on x86. Each core has its own inbuilt crypto assist module and on-chip compression chip. On-chip compression module. If a major core fails, then it automatically swaps in another one. Customer doesn't even notice. 40 terabytes of RAID memory and 85 hard partitions on the full-size one. Some of these numbers coming up the next few, so 4 levels of cache. No, the level 4 cache doesn't exist on most other servers. And then every LinuxOne machine has offload engines. So the only work that the main core does is the number crunching, the actual CP stuff. Everything else is offloaded to assist processes. So there are up to 22 IO processes, and then in the far right column, each network interface card or IO adapter has an additional 2 cores on it, not the same speed as the major ones, but they're all doing everything they can to speed up and be as efficient as possible as getting data in and out of memory. And there are it says up to 5,376 smaller lightweight processors. They're embedded on the IO adapters or the NICs or whatever. It could be even on the crypto cards. There are additional cards you can get. So that's the full size one. Not many uses in New Zealand for that, I would think, but the smaller ones are more likely. And then there's the smaller one. So the only difference architecturally is the number of cores you can have. Everything else is the same. It's all built on the same hardware. It's the same IO cards. It's the same everything, microcode, the lot. You're just limited in the number of processors because we're only a one-frame machine. Okay, so one of the key reasons why LinuxOne is an option for consolidation, not just in terms of power and footprint and management overhead, is the architectural differences. So the clock speed, if your application is clock speed dependent, then the LinuxOne clock speed is higher than the average Intel core clock speed, so up to 2 times. If your application is IO dependent, then there are hundreds of engines capable of running the IO offload to free up your CPU to run harder and harder. Workload management, higher CPU utilization. The average Linux box and LinuxOne machine, I should say, runs sustained CPU utilization at 80 to 90%, and it is more than capable of running at 100. Whereas the average utilization on Intel x86 servers around the place is 10 to 20% conservatively. So you're going to automatically get 3 to 4 times better performance per core. The machine is built on the back of 50 years of mainframe reliability and availability. The mean time for failure for the whole machine is in decades. Possible to achieve less than a minute's outage per year, depending on how you set it up and which machines you configure. And DR is a capability. You could have a secondary LinuxOne machine, take advantage of all the features of the storage mirroring, be it on the flash system or the enterprise class DS8s. So you just mirror once. You don't need the additional capacity to be there straight away. It's microcodable on the fly with a feature called capacity backup. And again, there's lots of options on how you want to do that. You could be on the same box and just a hot standby. You could be in different data centers. You can mirror across distance, just the same as any other storage device that the other guys might have run you through. Don't know if there's any questions at the moment, but I'll just flick into a couple of smaller client references. Some of them I can name, and some of them have links, so you'll be able to follow along, go along and have a look at what the real customer was saying. So this is a smaller customer. Well, he's not actually. He's a mid-sized customer. He's a telecoms guy. He was having cost problems, basically. The cost of Oracle was every 3 years they were getting a bigger and bigger bill, and their growth was starting to take off. This is about 2 years ago, this customer. So they had 80 x86 cores running Oracle, and they reduced that down to 10 in production by running it on a LinuxOne with a terabyte of memory, 3 terabytes of SAN attached disk. That's just the size of the databases. So at the time they had 10 production cores on the LinuxOne machine. They configured up to 32 because they knew this thing was going to grow. They had a 20% increase in SQL performance by doing nothing other than moving it onto a new machine. They didn't change their releases. They didn't change their application. It's all just technology benefit from shifting. Some of these clients are willing to share how much they saved in power, and this one, not so much. Here's an interesting engineering company out of England. They're a full case study. You can click on the link at the bottom there. Fort Vale is a foundry, really. They specialise in high-end stainless steel valves for the safe transportation of liquids and gases around the world. At the time, they're probably the world leader in this, and they were struggling to keep up with the amount of stuff going on. They're probably pretty quiet at the moment, given the worldwide lockdown, but there's still stuff being moved around. So their main driver was throughput, capacity. They were struggling to meet the demand for the number of transactions. 40,000 a minute is what they were getting, and they were peaking. And moving to LinuxOne, they moved to 370,000 transactions. Again, no change other than moving it from one hardware platform to another. Didn't change the database, didn't change the application, just the same Oracle releases. Their consolidation saves them 100,000 pounds, Great British pounds, in annual maintenance costs. There's more information on their case study site, and some more comments around how they did it and why they did it. Next up is a smaller customer, small outsourcing or managed service provider. They were experiencing growth again, and they couldn't really keep up with the customer demand in terms of someone wants a new rack every time, or someone wants their own capacity. They just couldn't keep up. So they migrated to a Rockhopper 2, which was the second generation LinuxOne single frame. So it's a smaller inbox, put 600 gig of memory in it. And they went down from 48 Intel cores to 12 cores total across the bank. So even if it doesn't say this is an Oracle client, I'm not sure it is, but by far our LinuxOne users are Oracle users. That's the biggest workload on Linux, on Z by far. They're planning capacity on demand, so you can upscale this machine, without an outage. You can go from 12 CPUs to 24 CPUs. Batch jobs improved. And again, no changes other than lift and shift. If the product's supported and it's the right version, you can lift and shift. And here's one of one of two very large Chinese companies that have really adopted this ridiculously fast. So here's a customer with 200 servers, so 6,500 total cores supporting Java and WebLogic insurance applications. The Chinese government came along and said, you have some disaster recovery requirements. So these guys went to their managed service provider and asked for some space and energy to duplicate their environment. And they were told, no, we can't do that. We just don't have the room. You can't. So they looked at re-architecting it and re-platforming. And the solution in the end was, at the time, 2 LinuxOne, the multi-frame boxes. So that would have been generation 2, the Emperor 2 it used to be called. The 300 cores in total, they went from 6,500 to 300. That's across everything, dev, test, production, using OpenStack and KVM. So pure open source. And they reduced their VM, up the top there it says Oracle, and VM and Citrix was tens of millions of dollars. As you can imagine, with that many servers and cores. We're going to open source. In the most part anyway, they kept Oracle. They're still an Oracle customer, but their Oracle bill will have dropped significantly. They got an average of 21 cores to 1 as they consolidated. 90% software savings, energy savings are 75%, 70% of the floor space. And they can pick and choose whatever open source software they choose to. If they want to move, get rid of OpenStack and go to any of the other options, Kubernetes, OpenShift from Red Hat, it's all available. They're all supported. Alongside this Chinese company, there was another bank that at the same time was doing the same sort of thing. We don't have any information that we can share with you on that, but they're another huge customer. They now run 30 LinuxOne servers. They are by far IBM's biggest LinuxOne customer in the world. And that's in about a space of 2 years. So that thing there at the bottom there, the insurance company, was the biggest in 18 months. Yeah, that's been beaten by one of the banks. They see it as alongside the storage solutions where you can mirror everything from one site to another. They see this as the only way they can keep up with the growth. They've got banks with 100 million customers, which, when we think about it, especially in New Zealand, it's phenomenal. We're lucky to have a bank with 2 million. I would think maybe a bank touches 2 million customers, but they don't have 2 million customer accounts. These guys are huge. Yeah. So vendor lock-in, one of the important things about Linux, obviously, is you don't want to be stuck using vendor code and saying, oh, it's too difficult to get off, it's too expensive to get off. So if you're not an Oracle customer, or you have Oracle and a whole bunch of other open source stuff that ties into it, there's a whole ecosystem available on LinuxOne. It's all fully supported through various channels. Most of this stuff is supported directly from the vendor. So on the left, we go from the distributions that are officially supported, the top 3, Ubuntu, SUSE, and Red Hat. And then there's community editions that all have the Linux, the Z code, S390X is the platform. Embedded in it, they're all part of the tree. They're already there, whether you install it or not, just like any other Linux. It just detects the architecture and installs what it needs. Hypervisors, the teddy bear for some reason is a 1970s emblem they chose for ZVM, which is the IBM operating system that runs as a virtualization layer. LPAR, which is hard partitioning, and then KVM, which is part of the Linux distributions these days. And then all the way, you go all the way across Docker, Cloud Private, OpenStack, OpenShift. Docker is the flavor of the month. And at this stage, there are over 4,000 Z Linux or Linux on Z Docker containers available on Docker Hub. So there's plenty of development work, and there's just about everything you want to run, you could run. Most languages are supported, most runtimes, management choices, you name it, it's there somehow or other. You can even tie in your guests with VM Realize. You realize from VMware, you can use Puppet, Ansible for automation, Kubernetes, Chef. Databases. So Oracle, as I said, is by far the biggest consumer of LinuxOne Z or LinuxOne engines worldwide, but it's by no means the least. So anything that's so MariaDB, which is an old spin-off from MySQL before it was purchased. Postgres is considered an Oracle replacement without the Oracle tie-in. There's now a Fujitsu version of that, which is called Fujitsu Enterprise Postgres, which is fully supported by Fujitsu in New Zealand and Australia. And it could be an option if Oracle's starting to bite. MongoDB, Cassandra, Skylar, and then you've got your analytics on top of whatever you want to do. So there's Spark, which is an Apache Spark, and Elasticsearch. And this is just a bunch of them. There's so many to choose from. I'll find the proper link, and these are updated almost monthly. We have IBM has an open source department or lab somewhere, and they're constantly reevaluating and recertifying and creating binaries of most, if not all, of the things that customers are asking for. Some of them, some of them are too hard, or they just won't work due to the way they're written without redeveloping the upstream code. But most of them seem to be getting done when enough customers ask for them. There is a free community cloud where anyone who wishes to can sign up, no charge, no credit card information required. It's not one of those places where you have to give information other than your name and address, email. Anyone in the world can ask for access for 120 days that you get your own virtual server. You can install software on it, you can build software on it, you can test interoperability, you can use it to call other cloud services out there to test how it would work, functionality across multi-cloud. It's hosted in New York, just north of New York, in a place called Poughkeepsie, where the mainframe development is. And it's actually hosted at the college that created the first ever Linux distribution for IBM mainframes at LinuxOne, Marist College. Feel free to have a look. It really is cost-free. It's plenty of stuff you can do there and have a look around. And I think that's about it. If any questions come through, or I'll stop.
I have a question, Pat. When you talk about consolidation, sometimes it is, we had this discussion before. We talk a lot about Oracle consolidation, and we can reduce the software licensing. But also, I did a calculation like a few weeks ago. I sent you that we can really reduce the total cost of ownership. I did a very simple example, like cost of energy, right? So you can reduce. We were doing like a comparison with the 560 core machine, right? So we could have like 67% of energy saving just in 3 years' time. So that's massive. So if you replicate this type of calculation, it is not those website TCO tools that is a standard, a benchmark. I did a real one with 10 physical servers, 56 cores each, compared to LinuxOne, 560 cores total. And just from the energy consumption point of view, it was already a very good thing, right? So
yeah, so we have a when we're working with a client to determine the size of the machine they are looking at and what best fits them, we have a tool that will give them an accurate number of how much power it's ever going to use. So the single frame machine, it tops out at about 8 kVA total, fully loaded. That's all it would ever use for a 19-inch rack with 65 cores in it. I don't have enough information, or I don't know enough about how the x86 cores work, or how many you can get into a rack these days, but I'm pretty sure they'll be drawing more power than that.
yeah, and I could see that very clear. And if you add to that, like things like management, reliability of an x86, any brand. I'm not here talking about A, B, or C, but if you compare the x86 architecture itself and you compare it with against a mainframe or even power server architecture, you will see very clear that from the reliability point of view, there's no comparison, right? So that ITIC study that we were reading the other day, like it was massive, the reliability. Like LinuxOne mainframe was not even on the spreadsheet that we were seeing from the non-planned outages per year. So
yeah,
on that survey,
it's on average it's less than a minute unplanned outage per year for the LinuxOne machines.
So yeah, and against almost 2 hours for average x86. So that's massive.
Yeah. So
Especially
the reason you get the reliability and everything is, even though these machines only run Linux, they're only capable of running Linux by design, microcode enabled. The technology, it's all based on what IBM did over 50 years for the banks, when the bank said, we need this, our bank's got to be running all the time, and then e-business said we've got to be running all the time. So these machines are designed with multiple redundancy layers, so there'll be backups on backups in there for some of the key functions. Some of them will have duplicates. There's no single point of failure in these machines. You'd have to have a cascading failure to bring them down.
Yep. Yeah, that's massive. That's massive. I would open to the panelists to see if anyone else wants to make a comment on that one.
So this is Barry. I was curious, Pat, in regards to obviously a lot of the cost savings, particularly for Oracle, comes with the reduced numbers of cores, obviously, that are required to do the same amount of work. Oracle haven't turned around and come up with some funky way of classing them as more than one core or anything?
No, they haven't. They are, Oracle and IBM actually have a platinum partnership. They're quite tightly coupled in terms of how they support this machine. The core is rated at 120 PVUs, I believe. I'm not sure what that translates to in cost value, or what it costs the customer, or what an Intel core is rated at. But IBM and Oracle have labs where they work together. The day Oracle releases a version of Oracle, I don't know what we're up to, 18 or 9, maybe even more, 18 or 19, I don't know. On an Oracle box, for instance, it's probably only a matter of days before it's available on the Z machines. They have support. They have their own conference meetings. They have their own development teams. Oracle have a specialist Oracle on Z support layer. You won't go through to the x86 guy if you've got an Oracle on Z problem, and vice versa. So they really are quite tightly coupled.
Oh, that's good. That's good to know.
Pat, Andrew, I noticed Oracle tried to do a lot of things to encourage people to eat their own hardware. So, for example, they will say that a Z is one, a power is one, but BART branded x86 is 0.25. So in the Power Platform, we have to get greater than 4-to-1 efficiency to start hitting those licenses against an Intel platform. But the numbers you've shown us today are very encouraging. And you mentioned one of the values. Somebody was asking the other day what an IFL was worth, and it's equivalent to one core. So, which is in this case 120 PVU, as you say, which is an IBM licensing metric we use for our various software products. So that it doesn't have a fixed value in dollars. It's just the quantity of volume units, shall we say, that each core is assessed. So it's the highest there is actually. It's equivalent to anything with 4 sockets or greater in the Intel world. So if you've got anybody out there with an HP 8 socket server, you're paying the same software price as on a mainframe.
Okay.
Yeah, just it's Ben here, Pat. Just to add to Andrew's comment, I think the LinuxOne have a feature, or it's not a feature, it's just what we call hard partitioning versus x86 soft partitioning. And the way it works is in soft partitioning, it doesn't matter how many cores or how many VMs you have assigned to a core. Oracle will charge you on the full processor rate of that server, of the x86 server. So therefore, if you have 4 VMs, you're going to get charged 4 times. For full server number of cores, whereas on the LinuxOne, Oracle count us as a hard partition. So per LPAR and per subsequent sort of VM in an LPAR, we only get charged 1 or 1 core per core.
Correct. Yep. There's no double dipping or whatever you want to call it. Yep.
And it's worse than that in reality, because a lot of x86 platforms are virtualized using VMware. So you are potentially liable to license the entire cluster, because if any machine can run the workload, it has to be licensed. It's not like we have, as you say, a hard partition, but they recognize it as a hard partition, the LPARs and IFLs, but they do not for VMware. So theoretically, the entire cluster may have to be licensed for Oracle. So that's where you can get some massive savings.
Actually, on that VMware topic, so there's two flavors of virtualization that are officially supported by Oracle. One is their own Oracle Linux, and the other one is ZVM running on a LinuxOne machine as your virtualization layer. Any other time you run Oracle virtualized under VMware or whatever, or KVM, if you encounter problems, typically they will ask you to replicate it in bare metal or under one of the approved virtualization layers. So there's only 2 out there. One of us is Oracle and one of us is IBM. I know lots of customers run it under VMware, mainly because...
well, we have a tricky question here, Pat. I don't know if you are able to answer that, or Ben, because it relates to cost. So Enyo is asking, what would be the cost of a single frame rack with 64 cores? It depends if it is an end of quarter or not. It depends.
Yeah, are you? Yeah, no, that yeah. I'll ever talk to you later, Anna.
Yeah, so that would be the equivalent of an x86 farm that has over 120 servers and probably over 1,200 cores on an x86 equivalent. So I don't know if you meant 64 cores on the LinuxOne or 64 cores of a Intel equivalent, 64 Intel cores, and what's the LinuxOne equivalent? But yeah, we can take that offline.
Yep.
Yeah. If it is that okay, can we send you an email right after the session just to get more details on your inquiry, so we can respond with more for higher accuracy. I mean, so any more comments, guys? Otherwise, it was a easy one. Can we wrap up?
Yeah, Thank you very much. Yeah,
okay.
any questions that come through, if you're thinking about it later or whatever, feel free to fire them through to one of us and we'll get to it.
Awesome. So thanks, thanks, Pat. Thank you for the panelists today. Very interesting and assertive comments and questions. Just to say that next week we are here again. So every Wednesday, 4 p.m. New Zealand time, we're going to run the session number 7. So please make sure that you're registered because you need to have the approval from us from the systems, and then you will receive the link to go to the event. Leave your comment. Don't forget to leave your comment. Ask as many questions as you possibly can. If you want to run a TCO and return of investment study in your environment, please shout it out. So we are happy to do it. This is something very, very easy for us to do.
And just on that, the TCOs are free. It's a free service, so don't think it's going to cost you.
And it's even better. And did I forget anything else? So okay. So I will, as usual, I will upload this recording into our YouTube channel, and the material of this deck is already available on the public folder of the event as well. So just go to Barry's blog over there and /systems back to school, and every single information will be there. Replays, material for downloads, and registration for the 2 remaining sessions. Okay, that was easy. Thanks, guys, for attending today's event. Kia kaha, take care, stay safe. See you soon.
All right, thank you.